Hi everyone. Today I wanted to broach the subject of splitting a database, and because it goes hand in hand with it, I'm also going to be talking about establishing a persistent connection. Now, I have an article on my website about splitting a database. You can review it. I'll include the link below. And I wanted to go over briefly the whys of why do you split a database. And, we talk about performance. We talk about reducing network traffic, possibly. But for me, there are three main reasons. Number one, if you're going to have multiple users, you have to split the database. So right off the bat, multi-user split. Number two, and it goes hand in hand with that multi-user, is by splitting the database, you reduce corruption. And you can also limit corruption to just one side of the database. Let me explain. In my experience, I've had issues where I've had forms typically become corrupted. Well, if I have a split database, the form will get corrupted in the front end, but my back end remains intact, uncorrupted. So it may be a way of protecting either the front end or the back end. You never know what's going to corrupt, but in my experience, most of the time, for me at least, it's been the front end that gets corrupted. It's no big deal. I just delete the front end, I put in a fresh copy, and everything's good. But if you don't split the database and it gets corrupted, well, now everything is corrupted. And then you have to try to salvage things or restore backups. But if you've split it and it's your front end that gets corrupted, then it's nothing more complicated than delete and copy over a fresh copy of the master copy. And lastly, the big other reason to split is the ability to update a database. Let me illustrate that to you, because I don't think a lot of people understand that. Typically, we have an unsplit database scenario. I'm going to have a database. Let's open it up. And in my database, I have everything. I have my tables, my forms, my reports, everything's there. Now, the client calls you up as a developer and says, I need a new report. And you go and create an updated version of the database. And I've got my new report in there. Everything's glorious. So I go over to my client and I bring over my new updated version. And now I want to update it on the system. Okay. Well, now I've got to boot everyone out of the database. And then I've got to come here and I've got to open my database. I'm going to have to go and delete the tables. And I'm going to have to import the tables from his version that he's been using in production, right? I'm going to have to delete this guy. And I'm going to have to come and import. I have to go get his copy of the contacts. Okay. Now this may not seem like a big deal, and then you close it up and you go and you put that in place on his server, and then they can all get back into it. Now, for a simple, quick thing like that, it's no big deal. But let's be serious. Most scenarios, we're not talking about a single table. And most places, it's not always easy to get users out of a system. And if it's a mission critical database, well, then asking them to exit during work hours isn't possible. So then you get into, okay, now I need to do updates after hours. It's just very complex, or it can be very complex. But if we look at the case of a split database, so I have a front end here. So the front end has forms and reports. It has a link table. The table isn't actually there. It's just linked to it. The table is actually in the BE, the back end. So if we open up the back end, you'll see the table is actually there. And now I want to update this front end with the new report. So you as a developer take the front end and you do what you have to do. And you create your new report. And well, what do you have to do? Well, all you have to do in reality, no one even has to get out of the system. You don't have to ask any users to stop working. You delete your linked table. You go, and now when you get to your client, you're going to come here Well, you're going to create a new link table. And you connect to the production table now rather than the one you had on your computer. And you're done. Now you just put this on the server for the users to use, and that's it. But you don't actually have to create downtime. You don't have to ask everyone to exit. You don't have to necessarily do any updates after hours. You can do this while they're working, replace it on the server, and the next time they close and restart the database, they get the new updated version. So that's one of the big benefits with a split database is you can do updates live in real time without impacting your users if it's just the front end. Okay. Now let's get to the heart of the matter. We know that we should be splitting a database, and because of the ability that it affords you for updating and also possibly limiting corruption to the front end, for me, you should actually be splitting even a single user database. It segregates and limits corruption, and it just facilitates updating. So how do we split a database? Well, it's actually extremely simple. So let's open up our database. So as you can see here, we're back to the single database where everything's contained within it. And it's extremely easy to do. We come over here to Database Tools, and over here in the Move Data, the button is actually called Access Database, and I've never understood why they give it that name, because in reality, if you press on it, what are you getting? You're getting the Database Splitter Wizard. So why they don't call it Split Database, anyway, we're not going to go there today, but that is what you have to press, Access Database. The wizard comes up. In reality, you only have one option, split the database. So you press the button, and you're being asked, what's the name for the back end? So you want to be able to identify which one's the front end from the back end. So normally you're going to give it something that identifies that. And by default, they put BE, which means back end. But you can rename it to whatever you want, but I leave it as the default. It just makes sense. And you tell it where to put that. So I'm going to leave it on my desktop. You say split, and it's done. And as you can see, the table here, if we open up the BE for a second that was just created, as you can see here, when it opens up, on the back end, the table is local. If I put my cursor over it, as you see, all I get is contact. If we go on the front end, we know it's a linked table because, one, it has that little blue arrow. I know it's hard to see, but it's a little blue arrow. And when I hover over it, it's actually giving me the path to where that table is located. So I know it's not located in my database. It's actually located in C users Daniel desktop demo BE ACCDB. So that's my backend database. So I now know this is a split database. Okay, so that's how hard it is to split a database. What I'm going to say is as soon as you split the database, in reality, you should be opening up that backend. You should be adding a password to your database, your backend. You want to secure your data. Let's not kid ourselves. Let's not beat around the bush. We all know how important data is nowadays. And the least you can do when it comes to access, at least, we're not talking about SQL Server and other backends, but when we're talking about an access backend, the least you can do is come on info here and encrypt it with a password. Now, what's just happened here? If you just open a database regularly, you can't encrypt it because it isn't locked. It isn't in exclusive mode. Now, if you've seen my previous videos, you can use my right-click context menu and you'd have the option to just come here and open exclusively. But let's pretend for a second that you don't have that utility. How do we open a database exclusively? We simply come here. We're going to pick open. And then I'm going to browse just to simplify my life. And I'm going to come here on my desktop. I find my database that I want to open, the backend. And here under open, you click the down arrow and you say open exclusive. Now it's opened, it's locked. I'm the only one in, no one else can get in. Now I can go file, info. Now it will allow me to encrypt it with a password. Here you put your password, you confirm your password, you say okay, and you're done. Now that database, if you try to open it, will require the password to open. Now, one thing about that, As you can see, it requires the password. Now that we've done that, we've secured the back end, but now we have to update that in the front end so it can still access the database. Because remember, when we split it, there was no password. So the linked table doesn't have the password to unlock it. So if we open the front end, you'll see here, if we try to click on the table, we don't have the proper password, so we can't. So what I do normally is I'll just flush the table, I'll delete it, and I'll come external data from a database access, and we're creating a linked table. We'll go get the backend, so on my desktop, backend, and it's going to ask me when I say OK for the password. And then I select the tables that I want, and it gets imported. And now if I double click on it, the password is part of that connection. It knows it's embedded in Access. So we still hover over, we know it's a linked table, it's got the blue arrow, it's still pointing to my backend, but now it's got that password as part of it. So now we've at least secured the backend as much as we can. Then the question becomes, should you or should you not also encrypt the front end from Access? That's a personal choice, it's up to you, but that is the bulk of splitting a database, and I highly encourage you to encrypt the backend. Okay, we've done the splitting. Now, some people have asked me, how can I split a database manually? And it really is very simple. You don't have to use the command if you don't want to. So what do? Well, first things first is you make a copy of the database. Okay, so copy it, and we'll put a second copy here. And we're going to rename one of them so we can identify it as the backend. So I'm going to do exactly the same thing. I'm going to call it BE. So let's open up the BE. And what's supposed to be in the BE? Well, the table is supposed to be in the BE. So we can get rid of everything else. And a good practice here would be a compact and repair. And we can close it. And I'm going to use my right-click menu. I'm going to open it exclusively. I'm going to come down to Info, Encrypt. I'm going to add my password. And my backend is ready. Now I'll open my front end. And what's supposed to be my front end? Everything but the table. So I'm going to delete the table. And I can do a compact and repair. And I'm going to go and create my link table now. So it's going to ask me for my password. I enter the password. I pick my tables. Okay. It creates a link table. I hover over it. I know it's a link table. It gives me the path. And that's how hard it is to do it manually. And that's it for splitting a database. The next thing I wanted to discuss today was persistent connections. Once again, I have two articles in reality. The first article talking about splitting the database also covers briefly creating a persistent connection. I also have a second article dedicated to persistent connections. So you can peruse them. It explains how this works or what we need to do exactly. Now, the question becomes, why do we need a persistent connection? And let me demonstrate. If we open a database, and we open a table to work on it, you'll notice here on my left side, it created a lock file. If I close the table, pay attention to that icon at the bottom, the lock file will go away. And then if I open a form, the lock file reappears. I close it, it goes away. I open a report, it opens, the lock file appears, I close it, it goes away. What's in a lock file? Well, a lock file is nothing more than a text file. If we open it up in the text editor, you'll see here that it gives the name of the computer and the person that's currently in the database. So what it is doing is it's actually logging and controlling who is currently accessing the database. Now think of a scenario in a corporate environment where you have multiple users and the lock file is being created, deleted, created, deleted, created, deleted. and then multiple people get in it, and it's getting updated and removed, and you see there's a delay too. It's got to go to that location where the backend is. It's got to check permissions. It's got to create the text file. It's got to enter the information. So all of these operations are intense and they slow down processes. So what does a persistent connection do? Well, a persistent connection at the beginning of the database, as soon as it opens up, creates the lock file. It doesn't wait for you to get into a table or a form or a report. It just goes and creates it right off the bat. And then it doesn't close it. It doesn't allow it to get deleted. So it's persistent. It's always there until which point you actually close and exit out of the database. So you're done working. And it keeps basically a telephone line open to between the lock file and the database, so they can talk faster with one another, and there's no more create and then delete, create, delete. Now all it is update as required, if there's requirement. But in reality, there's nothing to update, in the sense that when it creates it, it puts in the pertinent information, and when you exit, then it removes it. So it only does the operation once. From a performance standpoint, adding a persistent connection can have drastic impact on performance. Quite often in forums, whenever I see people talking about slow databases, slow design view, when they switch into design view, it's very slow. Quite often, adding a persistent connection resolves that issue. People just, they're not aware of persistent connections, and they also underestimate the impact that it can have on performance. Besides the proper indexing of tables, I think this would be the second most important element to optimizing performance in a database. It's creating the persistent connection. So how do we do that? Well, it's actually very simple. To create a lock file, as we've seen, we need to interact with the data. We need to, because we want to create a persistent connection to the backend. We're already in the front end there. That's done. What we're trying to achieve here is a lock file against the backend. So we would need to interact with the table. So how do we do that? Well, very simply. So first things first, we have to go into the backend. And the way I do it, we enter a password, is I'm going to create a new table, and you can put whatever you'd like. I just create a bogus table, bogus information, and you can name it whatever you want. There's no right or wrong here. You just want to make a very simple table with very few entries. And I'm going to call it normally I call it persistent connection. You can call it whatever you'd like. I just find this is obvious. And when I'm looking in my front end, I know exactly what that table is for. But you can name it whatever you'd like. And then I'm just going to put in an entry or two. Now, I'm done. The back end is done. We're done. We created a table. We close it. Now we go into the front end. And the first thing we're going to do is we're going to go get that linked table. Okay, we have the backend persistent connection table now. We can double click and confirm that everything's good. Now I'm going to create a form based on that. So we can just use the automated form. It's not going to be used by anyone. We really don't care what it looks like. Just let Access build it for you. Close it, save it. And now the next thing we want to do is, like I said, we want this to start up right from the beginning as soon as the database opens. So to achieve this, we have to create a macro. I'm going to use the run code action, and we're going to call up our VBA function. We're going to create next. I'm going to call mine startup. And that's it. We save it, and we have to give it the name of autoexec. And if you're not familiar with autoexec, an autoexec macro is automatically executed. That's what it stands for. So when the database is opened, as long as the content is active, so it has to be in a trusted location or be a trusted document, but as long as that's set up properly, and if you don't know how to do that, look at my other video. I'll include a link for it below. But when you open the database, that macro gets run. So what happens? We open the database, that macro runs, and that macro tells it run code. So next thing we have to do is write the code that we want to run. So we're going to insert a standard module. So if you look here, not a class module, we want a standard module. So we insert a module. I'm going to give it a name that means something right off the bat. So I'm going to call this my startup module. And here we have to create the function that we referred to in our macro. So I'm going to create a public function startup, just like what I called in my macro. Now, normally, just for reference purposes, we're not getting into it today, but normally this is where you'd have your relinking routine. Okay? And then the second thing, once we know the tables are properly linked, the next thing we'd be doing is persistent connection. Okay? Now, to do this, I segregate it into separate functions. That way it's compartmentalized and it helps troubleshooting, and it also means I can copy paste functions easier and things like that. So what I normally do here is I call my establish persistent connection function. And I put an S because some databases have more than one backend. So that's why I call it establish persistent connections. And now we're going to create the public subroutine establish persistent connections. And where this is as simple as a single line of code. The do command, open form that we created. And what was the name of our form? Persistent connection. And then we don't have to worry about all of these. The defaults are fine. The important one is this one. Open it hidden to the user. They don't need to see this form. We just want it to open in the background, hidden to everyone, as soon as the database opens. By doing that, it's going to connect to the table and create the lock file. And when you close the database, it automatically closes that form as well, releasing the lock file. So now let's look at how this works. We'll close that, and we'll even close down the entire database. So now when we launch the front end, we launch our database, look at the lock files. Both lock files got created, both for the front end and the back end, but we haven't actually opened any of the tables or forms or anything, yet our lock file is there. Now if I go and open my form, it's instantaneous. If I open a report, it's instantaneous. And even if multiple users are set up in using the front ends, they'll also have great performance. So all we're doing is creating this lock file. And when we close the database, the lock files go away. We reopen the database, then it's going to recreate those lock files. So that's what a persistent connection is. And as you see, it's very simple. It's just one more linked table. Some people connect to existing tables, but I avoid that. I create a separate table because it avoids any issues with locking of records. Or if you connect to an existing table and you have record locking, row level locking, anything like that, you can actually lock records from being edited. And then if a user needs to edit a specific entry, they may not have the capacity to do so. So by using a separate table, you avoid that issue altogether. And as you saw, it took 2 seconds to create one bogus table with a bogus entry in it. So I just hope you understand what it is and why you're doing it. It's a best practice. You really should be doing this with all your databases, and it has a drastic impact on performance. So we're going to wrap it up there for today. As usual, thank you for watching. Like, subscribe, give me a thumbs up, and leave me comments. I'd love to know what you'd like to see in future videos. Take care, guys, and have a great day.